Okay. Welcome to Math 1111, Lecture 1.1. I'll be going through the PDF lecture notes that I posted in the D2L under the Content tab. So what I've done is basically gone and taken screenshots of those PDFs and put them onto a PowerPoint slide, and I'll go through that. I'm going to try to keep this right around an hour. If any of y'all need to leave before I'm done, don't worry about it. Just log out. Of course, this is an optional lecture anyway. The way I'll run it is I'll go through slide by slide just like I would if I were standing in front of you in a classroom. I don't have our calculator loaded onto my computer, so I might have to do a little bit of this number to show you what I'm talking about on the calculator, because that's a lot of what 1.1 is about, just kind of learning how to go about looking at functions as well as some techniques for using your calculator. So if you have any questions while I'm going, you can just raise your hand and I'll get the little icon and it'll ring a little bell and tell me there's a question. And then once I talk about a concept, what I'll say is everybody okay with that? And you can either give me a green check or a red X. If I see the red X, I'll back up and say, okay, what did you have questions about with what I just said? So feel free to jump in at any time. You can either, if you have a question, you can either click your talk button, which is right under the window at the top left corner, or you can type it into the chat window. Some people don't like talking on the microphone, but it's much quicker if you'll just hit the talk button and talk. But if you want to use the chat feature, that's fine too. Okay, so let's go ahead and get going. By the way, let me just do a quick check. Everybody raise your hand real quick so that I can make sure that everybody sees that function and is able to use it. Hello, Lakin. There. Oh, she's approving, and she raised her hand. Excellent. Okay, so you can click that button again to put your hand down, and everybody go ahead and give me a green check. Sorry, I forgot to turn my phone down. That's my husband's rockin' ringtone y'all are hearing. All right. Okay, let's go ahead and get going with this. Where's my pen? There it is. So I'm using the tablet, so I'm not as quick with it as I am with my keyboard and mouse pad. All right, so the first thing that you encounter in 1.1 is the rectangular coordinate system. That's the good old X and Y axis that you're always used to seeing. So it's basically a place to plot points, graph functions, things like that. Each point in the system looks like, let me make sure I have my pen here, sorry. I'm going to write in blue so that it stands out from the notes here. Every point in the system looks like the point X, Y. So once again, if you've got your own PDF printed out, you can be filling out these notes with me to keep in a notebook if you want. If not, you can just follow along. I do encourage you to work the problems when we get to them so that you can make sure you don't have any questions about it. And Lakin and Taylor, y'all know the drill with this. Y'all have been in my math classes before. Dave, so that's what I would ask you. Let me tell my husband real quick I'm lecturing. Thank you. Sorry. Hey, babe, I'm in the middle of a lecture. That's okay. Nope, online lecture. Remember the synchronicity we talked about? Nope. Love you. Bye. Sorry. All right. Where each point is located by first identifying, well, if you look at the point X, Y, X corresponds to your horizontal axis. So that's what you locate first, is the point's horizontal position. Sorry, that says horizontal, I swear. And then once you move in the horizontal direction, then you locate the vertical location. And then you plot the point. So there are a couple things to know about the Cartesian plane here, which is what we have in front of us, the rectangular coordinate system. A very important point is where the two axes meet, known as the origin. That is the point 0, 0. The two axes split the split the plane into 4 quadrants. We always start numbering the quadrants in the top left. This is where all the points are positive. We have positive x values and positive y values in the first quadrant. And then we move counterclockwise to name the other 4. Notice that they're all named with Roman numerals. So you do not name quadrants with Arabic numbers. By the way, our number system is Arabic. So we don't name with Arabic numbers. We name with Roman numerals when we're talking about quadrants. Every point in the second quadrant has the characteristic of being a negative x value and a positive y value. Every point in quadrant 3 is negative x, negative y. And every point in quadrant 4 is positive x, negative y. So take a moment and on your own paper, see if you can plot these points real quick. I'll give you just a minute or so to do that. A little bit of background noise to make your plot pointing extravaganza more pleasurable. Okay, I'm going to go ahead and start so we don't waste too much time here. 1, 2, you know what to do. All right. So, point A, we have the directions given to go -4 in the horizontal direction and +3 in the vertical direction. So point A lives here. -4, 1, 2, 3, 4, up 3, 1, 2, 3. Point A is listed right there. And this should seem really easy to you. This is old stuff. Notice I labeled the point with a capital letter, not the coordinates of the point. We always label points with capital letters. Should you be labeling points and make it all the way through the alphabet, you start doubling the letters. So AA, BB, CC, all in capital letters. Okay, so point B is -1, -1, so left 1, down 1. Point B. C is 0, 3, so left to right, none, up 3, right here. D is +2, -4, so right 2, down 4. Can't believe I'm actually hitting the mark with these points. I'm still not that great with the bamboo tablet. Point E, 3, 0, so right 3, up or down, none, sitting right on the axis there. Okay, is everybody good with this first little bit of material? Green check or red X? Green check, green check, green check. Excellent. Let me clear those marks out, and I'll go ahead and move on to the next slide. Okay, so graphs of equations. Graphs of equations in 2 variables show up in our rectangular coordinate system. And here's a nickel's worth of free advice. If you ever encounter a function, and I'm saying a function because it has X and Y in it, so I can go to the graph and graph it. It's a mapping of input to output. and actually, to be specific, a function maps each input to one and only one output. We'll talk more specific about functions in a later section. But say you're just given this equation here, and you're asked to figure it out, to graph it, or to answer a question about it, and you have no idea what to do. The first thing that you should do is start trying to make an XY table to start graphing that thing. Now, notice, I've chosen these 5 input values. However, these values don't have to be the input values that I choose to use. We normally use these values because they're nice and neat right around the origin, but with functions, we can use any input values that exist in the domain of the function. That is a word that will be defined in a later section as well, but just to give you an idea, domain is all possible input values. For this particular equation, it's a quadratic function, meaning it's squared, and there's no real number that you can't square. So your domain is not restricted at all. So if you wanted to plug in negative 9,867,472, you could. You probably wouldn't want to, but you could. So let me just show you how these points were generated, and then they were plotted. I've got it color-coded there for you to see. But the points were generated by plugging in the input or the x values and getting back out the subsequent y values. So I started with y equals, well, my first input value is -2. Now notice, whenever I plug in a value, I always use parentheses, because this will actually give you a different answer. -2 squared and -2 squared are absolutely not equal to each other. The left-hand side is the same thing as saying -1 times 2 squared because of order of operations. The right-hand side says to multiply -2 by itself. In other words, square it. So according to order of operations, I do exponents first. This is -1 times 4. -2 times -2 is +4, so -4 does not equal +4. So that's just kind of a side note about evaluating a function. That's what we're doing when we plug that value in to get a value out. So you can see how important it is to put that input value in parentheses when I'm evaluating it. So y equals, this is +4 minus 3. Y equals 1. So you can see here we get that point, -2, 1, which lives here on our graph, left 2, up 1. So that's how all of these points were generated in my table of values here, as well as on my graph. So the graph of an equation in 2 variables is a set of all points whose coordinates make the statement true. In other words, when I'll take a different point as an example of that statement there. Let's take the point 1, -2. If I plug in both the x and the y value there, it's going to make my statement true, meaning it is a solution to the equation. If it's a solution to the equation, it is a point on the graph of the function, and vice versa. If it's a point on the function, it's a solution to the equation. So let's see how that works out here. So I'm using the point 1, -2. My function is y equals x squared minus 3. So I'm going to plug in -2 for y and 1 for x. So -2 equals 1 squared is 1 minus 3 -2 equals -2. There's the true statement we're talking about. So if a point makes the statement true, it's on the graph of the function. If a point is on the graph of the function, it makes the statement true. We call all of these are solutions that we are generating. Everybody good? Check, check. Lincoln, you all right? All right. Okay, moving along. I see you're typing something, Lincoln. You forgot where the check was. All right. Okay, so if you want to give this one a try on your own paper at home, graph the following. So you can choose whatever x values you want. I suggest you stay right around the origin. So you might as well just use -2, -1, 0, 1, and 2. Think about the restrictions on being able to plug into this. Is there any real number value that you can't take the absolute value of? No. So there are no restrictions on plugging into this function. So I'll give you a couple minutes to try that on your own. Maybe not a couple minutes, maybe just a minute. All right. I knew what it was supposed to look like. That's how I knew I needed to add a couple more values on. If you had just gone with -2, -1, 0, 1, and 2, you would have thought it was a line. Sorry, but I went ahead and added 3 and 4 in there. So we got the 0.31 and 4.2, which kicks it back up the other way. So your absolute value functions are going to look like a hard V, either right side up or upside down, just depending on if it's a positive coefficient in front of the absolute value sign or a negative coefficient. You don't have to know right now about absolute value so much as the process of choosing input values, placing them into the function to evaluate, getting out your y values, and plotting them on the graph. Is everybody cool with this? Does anybody have any questions about that? Everybody's good? Everybody's good. Lakin, you weren't the last one to check this time. She knows where the check is now. All right. Graphing equations and creating tables using, they call it a graphing utility. That's just your graphing calculator. Okay, so the graphing calculator that is suggested for this course is either a TI-83 or a TI-84, or an 84 plus is fine. This is what the TI-84 plus calculator looks like. The TI-83, actually I'm trying to figure out how to turn this so that, there we go. It's hard to be working backwards with the camera there. The TI-83 is the same exact calculator. It looks a little older and clunkier, but it does the same exact thing, and except it has a little bit less memory in it. You can, one of my other students, one of my face-to-face students, just picked up a TI-83 calculator. I think she got it on eBay for maybe 30 bucks, is what she said. So you can go out and get a TI-84 and 84 plus. That's what they're selling in the bookstore. One of my other students told me the bookstore had it for like $120. Like I said, if you don't want to blow that kind of money, just go get yourself an old TI-83. Buy it from somebody used. It's the same calculator. All of the same instructions apply to the 83 calculators, and it'll save you quite a bit of money, almost $100. Maybe even $100 if you find it cheaper used than 30 bucks. Okay, so a few things about the graphing calculator. Graphing calculators or graphing software packages for computers are referred to as graphing utilities or graphers. You really didn't need to know that. Anyway, we'll go on. Below is the notation for. Okay, so this notation that I'm talking about right here. Whenever you're using a graphing calculator, if you've got instructions, like written instructions on something, you will be given this notation here. What this notation is for the standard viewing window. And let me interpret this for you. The first set of brackets is always going to be corresponding to your x-axis. The second set of brackets will always be corresponding to the y-axis. So what this says, this first set of brackets says -10, 10, 1. What this means is that the x values, the horizontal axis that you'll be viewing on your calculator screen, goes from -10 to 10, counting by 1. So the same thing for your y's here. This says -10 to 10, counting by 1s in your vertical direction. So it's basically giving you the scale for each of the axes. You have a TI Inspire, but it's converted to an 84. I have no idea if that is, I don't know what TI Inspire or T Inspire is. I'm sorry, Dave. If it's not, if you don't find that you can use the same commands that I'm going to talk about here, I'm not trying to put you off, but I've had a lot of students have success with just going on YouTube and finding videos about how to use their calculator. Okay, cool. All right. All right. So the meaning of the terms is demonstrated at the right here in this picture here. This is the window that you will get with the dimensions chosen by pressing window in the top row of the keys of your calculator. That's kind of a true statement because it depends on what was last set in your calculator. You can change viewing windows. So if you have your calculator, go ahead and grab it and click on the window key. So I'm going to show you where that is on mine. The window key is listed right here at the top. It's the second one. And it's going to bring up that window screen there. So you can see mine is actually set on the standard viewing window. It's -10 to 10 counting by ones, -10 to 10 counting by ones. Don't ever mess with your resolution. Unless you're specifically given instructions on that, just leave it. The XRes equal to 1. So you can change this by simply using your up and down arrow keys and typing in new numbers, and it'll give you a new viewing window. I'm just going to put in a general function into my calculator, and I'll show y'all how to do this in a little bit. X squared. Okay, so my calculator is set. My calculator is set on the standard viewing window, and that is the x squared function. So that's just a parent parabola there. Notice it's nice and centered up. It's counting from -10 to 10 by ones, and -10 to 10 by ones in the y direction. I'll show you that by clicking my window key again. You can see I'm on my standard window. If I change this, you're going to change the look of the graph. So I'm going to change my x-min is just your minimum value in your x range, and I went down, and it's actually to the left, your minimum value in the x or horizontal direction. So I'm just going to make it -100, and then I'm going to make my x max +100. And I'm still going to count by ones because I want it to distort the view for you. I'm going to do the same thing in my y direction. Okay, so I'll show you that I changed, oops, I hit a awful lot key. I'll show you I changed my window. I know that's hard to see. Let's see. There we go. -100 to 100 now, -100 to 100. And when I hit the graph button, which is all the way over on the right there, it will give the picture. So you can see it looks a lot skinnier. That's because I'm not just seeing -10 to 10 anymore. I'm seeing -100 to -100, same thing this way. So it distorts the view. If you go to put a function in your calculator and you get to your viewing window and it's nowhere to be found, my first suggestion is that you go back to the standard viewing window and see what that graph, welcome LaToya, you see what that graph looks like from the standard view, and you may be able to find it that way and then go and change your viewing window to see what part of the function you want to see. So your quick keystroke cut to get back, once again, I'm not in the standard viewing window anymore. To get back to the standard viewing window, I hit zoom, and zoom is the middle function key at the top. So zoom, and it brings up your zoom window. I want to go to the standard. That means zoom to my standard viewing window. So I press 6, and it quickly takes me back to -10, 10, -10, 10, counting by ones in both directions. So I'll point out on the sheet here, you have all that listed right there, that keystroke information. It will take you from whatever the window's set in to the standard viewing window just with that keystroke. Everybody good so far? Looks like we lost Lakin. Taylor's good. Dave's good. LaToya, I'm not sure if you're familiar with Collaborate, but right in the participants panel, you see a smiley face, a person with a clock, a hand, and a check in a box. Click your check in a box, and you can either give me a green check or a red X. So go ahead and practice and give me a green check. Okay, very good. So I was telling everybody before you came in the room, that's kind of how I do my check to see that everybody's good before I move on. I say, is everybody okay? And you either give me a green check or a red X. If you give me a red X, I'll probably ask you what it is you don't understand so that I can go back and explain it a little better. Let me get a sip of water. Cave spring water. Can't beat it. Okay, great. Thank you, LaToya. All right. Moving along. Okay, so your graphing calculator here. There are a few things going on. To input a function into your calculator, you use the blue, I guess on the 84 pluses it's actually gray. This is an older version of the calculator that's pictured here. You have to hit the Y equals button. That brings you to the screen right here. And if you keep going down, you'll have Y8, Y9, and Y0. You can put up to 10 functions into the calculator at one time, and you can look at them all at once if you want to. That would probably be a little confusing looking, but we do a lot of times put 2, perhaps 3 functions in at the same time. It can be very useful to be able to put 2 functions on the screen at the same time. So, first things first, if you put a function in, by the way, this is x squared divided by 9 that they put in here. If you put a function into the calculator and then you click the graph button to see the picture of it and it doesn't show anything and you think your calculator's torn up, more likely than not, a statistics student used your calculator before you did and has turned the stat plot on. So if you go back to your Y equals button and go back to the screen, if any of these plot functions are highlighted, you don't want them highlighted. That's the stat plot that's on. So what you do is you go up with your arrow key until it goes back on to whatever plot's highlighted and click enter, and it'll toggle your stat plot off. Click your graph button again and you should be able to see your graph. I can't tell you how many times students have said to me that their calculator's torn up, and it's just that the stat plot is activated, and it doesn't need to be because we're graphing functions. We want smooth curves that come out on our graph, not statistical data points. Not yet, at least, until you go into statistics, if you go into statistics. Okay, so Y equals button will get you to your function input window. And then it wants you to type the equation x squared divided by 9. So to type the x variable, there's this button here, x t theta n. It's located, let me get a different color so you can see that really pop out on the calculator over here. This is your variable button that you use, x t theta n. As long as you're in function mode in your calculator, if you hit that button, it'll give you an x. It won't give you a t or a theta. Those are for different types of graphing, or an n. It's for different types of graphs. It will give you an x. And then to square, there's a special key for squaring. It's located right here. That'll square it. However, if you want to put in an exponent other than 2, you'll want to use the caret function. So say I wanted to graph x to the 4th. I would use my x theta in button to do the x, and then to do the 4th, I would need to hit caret function and 4. And when you put that on your screen, it's going to look like this: x caret 4, and the caret, if you got one of the newer versions of the calculator, it'll go ahead and kick that 4 up into the exponent and erase the caret function for you. But your caret function is your raise to button for your calculator. So the next window you'll want to check is your table setup window if you're trying to make a table. And that is second. So your second key is located at the top left of your calculator, and window. Notice right above the window key is the second function for that key, and it says table set. So let me tell you what this means here, because it looks like garbledy-gook, really. TBL start equals 10. That means the table is going to start counting at the value 10. Triangle TBL equals 10. The triangle, that's actually the delta symbol in mathematics. That means change in or change by. So what the change in table equals 10 means is it's going to count in your table by 10. That's the change in the value when you go to look at the table. So if you look down at the picture of what you get there, notice the x values are 10, starts at 10, 20, 30, 40, 50, and so on. You can change that. If you go onto your table setup window, you can count by ones, you can count by pi, you can count by whatever you want to count by. You can start wherever you want to start. Even if you start at 10, you can always use your up and down arrow buttons to go further negative or further positive in the table. It's not like it won't go back to 0 or negative 10 or whatever. The independent right here, independent, dependent, you've got auto and ask that you can toggle on and off. If you want the table to populate itself, like it's done in the window down there, you want to leave your independent and your dependent variables on auto. By the way, your independent variable is your x, your dependent variable is your y. Don't ever change your dependent variable to ask unless you are instructed step by step how to go about doing that by a tutorial center or professor or whoever. Now, there are some times that you may want to toggle your independent auto to ask. So what happens when you toggle that, and all you do is arrow down, move over to the ask, and hit enter. And then if you go to your table, you won't see a populated table. At the bottom, you'll see x equals and then nothing. You'll arrow down there and say you want to plug in some strange value like negative 6.78. When it's toggled to ask, it will evaluate that for you and put it into the table. So that's the way you can picky-choosy what you want to evaluate instead of having the table populate itself. Now, if you want to go back to populating the table automatically, you're going to have to go back to this window and toggle back to auto. And to see the actual table, the table is the second function for the graph key. So you do second and graph to view the table of values. And that's just a regular XY table that we generated a few slides back ourselves. Your calculators do it for you. Yippee. Everybody good? Okay, Taylor's good, LaToya's good, and Dave is good. Sweet. All right, we'll go ahead and move on. All right, so I wanted to just kind of let you test your knowledge on the viewing window here. So take a few seconds and see if you can use the notation here to label the scale on the graph here. I'll give you a hint. This is 0, 0. And actually, you don't even need that on the graph. You want to, just in case anybody is confused with what I'm talking about doing, I just want you to label the numbers here. So this would be according to my notation here. Remember, this is my X and this is my Y. So this is negative 50, negative 40, negative 30, negative 20, negative 10, negative 10, 0, 10, because it goes from negative 50 to 50 counting by 10s. 20, 30, not 34, 30, 40, 50. Same thing in your Y direction. This is negative 40, negative 30, negative 20, negative 10, 0, 10, and so on. Y'all get the gist, don't you? Y'all good? Dave's good? Taylor's good? LaToya, you all right? Yeah, okay. Very good. Okay, so the concept of X and Y intercepts. In general, definition of an intercept is where a graph crosses an axis. So since we're working in the XY plane, we have X-intercepts and we have Y-intercepts. You're looking at the graph of X squared minus 4. And I didn't write this table out correctly. So if you've got your own page, let's redo this table here. Let's put 0, 0, and 0. All right, so to point out the X and Y intercepts, we have an X-intercept of negative 4. This is counting by 2s, by the way. And I'm sorry, I guess I should have written that. The X is going from, let's see, 2, 4. No, that was, sorry, it is not counting by 2s, it's counting by 1s. So we're looking at, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is showing you from negative 5 to 5, counting by 1s, by 1, 2, 3, 4, 5. Okay. So same thing this way, negative 5 to 5, counting by 1s. Okay? All right. So we have an X-intercept here of negative 2, 0, and an X-intercept here of 2, 0. So my first question to you would be, what do you notice about the coordinates of the points that are X-intercepts? Okay, I see nobody wants to speak. I'll just tell you what you should notice. Notice that both of the Y values for these X-intercepts is 0. So that is a characteristic of an X-intercept. For the X-intercept, the Y coordinate is always 0. You give the general form of an X-intercept as A0. That is the variable A, and then the Y value of 0. So no matter where that x-intercept lies on the x-axis, it's always going to have a y value of 0. Just the opposite for your y-intercept. So if you're landing on the y-axis, you're going to have an x value of 0, and we call the general form of a y-intercept 0b. We don't use x and y there because those are used in the functions. This is just kind of to name the general x-intercept and the general y-intercept. So if I go and fill this chart out, if I want to find an x-intercept, and this is how you do it no matter what your function is. If you ever want to find an x-intercept, you plug in 0 for y. So in this case, I have y equals x squared minus 4. So I'd plug in 0 for y. 0 equals x squared minus 4. Add 4 to both sides and get 4 is x squared. Take the square root of both sides, and x equals positive or negative 2. Don't forget, when you use the square root property like that in an equation, you have to take the positive and the negative into consideration. Because this equation here says, what can I multiply by itself to make 4? I can multiply 2 by itself to make 4, or negative 2 by itself to make 4. That's why you have to take into consideration both the positive and the negative. So it doesn't matter what your equation looks like. If you're ever looking for an x-intercept, you know that it's got to have a y value of 0. So you plug in 0 for y to find your x-intercept or intercepts, because obviously you can have more than one x-intercept. Now with functions, you'll only have one y-intercept, and we'll talk about how that is so in a later section. To find a y-intercept, it's the exact opposite. I'm going to plug in 0 for x. So for y equals x squared minus 4, y equals 0 squared minus 4, that's a 0. So y is negative 4. And you can see that corresponds to the point 0, negative 4 right there. So whenever you want to find a y-intercept, you plug in 0 for x. Rule of thumb, whatever intercept you're looking for, plug in 0 for the opposite variable, or for the other variable, not opposite variable. Everybody okay so far? Dave says yes. Taylor says yes. I see LaToya's got a lag on her audio, so maybe she'll catch up with us and check yes here in just a second. Okay, I'm going to go ahead and move forward then. Sorry, LaToya. Okay, good. I see your check now. Great. All right. So, find the x and y intercepts, and once again, bad xy table there. Find the x and y intercepts and graph the equation after plotting a few more points. So, to find my x-intercept, I'm going to plug in 0 for y. 0 equals the absolute value of x plus 2. 0 equals, okay, this is, I don't really want to go into the ins and outs of solving absolute value equations right now. Let's just scratch this one. I think we know how to find x and y intercepts. I really don't want to bog down in talking about, and Taylor, you were with me last semester when we did absolute value equations, so I'm sure she knows exactly why I don't want to go into absolute value equations right now. So we'll go ahead and move down to this equation right here. Take a minute or so, and this is a quadratic, so don't worry about the absolute value stuff. Find the x-intercept or intercepts and the y-intercept for the equation listed here. Y equals negative x squared plus 9. I'll give you a moment to work that on your own, and then I'll start working it on the screen here in just a minute. Okay, so to find the x-intercept for y equals negative x squared plus 9, I plugged in 0 for y, and then I started solving the equation. So I have 0 equals negative x squared plus 9. I subtracted 9 from both sides and got negative 9 equals negative x squared. Divided the negative 1 off of both sides because when I use the square root property, I need to have the x squared isolated. I certainly don't want to be taking the square root of a negative number if I want to get a real number out. And so I divided the negative off of both sides, and then I took the square root of both sides and got that x is equal to positive or negative 3, which corresponds to the points 3, 0 and negative 3, 0. For the y-intercept, I did just the opposite and plugged in 0 for x and got y equals negative 0 squared plus 9, which is y equals negative 0 plus 9, or just y equals 9, which corresponds to the point 0, 9. So I had 2 x-intercepts and 1 y-intercept. How's that? Dave says yes. Taylor says yes. Latoya says yes. By the way, we've only got one slide left of work to do. We're going to finish on time. Yippee! Okay, so this last slide, I know it's a little difficult to see. It was tough fitting everything on this one slide here. What you're seeing here are divorce rates for couples who marry in their teens. The line graphs in the figure there show percentages of marriages ending in divorce based on the wife's age at marriage. The red line shows, and so your time is plotted along your x-axis, and you're going to find that that's always the case. Time is always plotted on the horizontal axis, and that's so that you can show what's happening as time moves on. So the x-axis shows the years after getting married, and the y-axis, or the vertical axis, shows the percentages of marriages ending in divorce. The red line is showing marriages when the wife is under the age of 18, and the blue line is showing when the wife is over the age of 25 when they're married. You can see just from, a quick glance at the graph that obviously the younger the girls are, the quicker they get divorced, basically. It rises quicker, and it rises more than the blue line does. You probably are having difficulty seeing the models here, and whenever we have an equation that is modeling data, we call it a mathematical model. So that's the terminology that they have listed right there. I'll write them bigger for you. So the mathematical model for girls marrying under the age of 18 is D, or divorce rates, or divorce percentages, equals 4N plus 5. And for 25 and over, it's D equals 2.3N plus 1.5. Okay, so the questions below ask us to use either the mathematical model or the graph to determine different characteristics about this population. So A says use the appropriate formula, so mathematical model, to determine the percentages of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. Notice you're told here that N is the number of years after marriage. So in this first question, you're going to plug in 15 for N. And I'm going to use this top mathematical model because that corresponds to girls who get married 18 and under, or under the age of 18. So for A, I start out with D equals 4N plus 5. We're given 15 years after. So D equals 4 times 15 plus 5. D equals 60 plus 5. Wow. D equals 65. That's a percentage. Remember, our Y value, or in this case our D value, is standing for percentages of marriages ending in divorce. So 65, what that model tells us is that 65% of the marriages end in divorce within 15 years if the girl was less than 18 when they got married. Pardon me. B says use the appropriate line graph. So we're not going to use the mathematical model and calculate it. We're going to look at the graph and see what it says. So it says use the appropriate line graph to determine the same thing. So what this is going to do is going to show you that there is always going to be a slight difference in a graph, because graph is actual data points making it up, and a model that has been formulated to fit the graph somewhat. This is a line. This equation is the equation of the line. You can see here that this red graph is not, I hate to say straight line because all lines are straight, it's a curve. So it's not going to be exact, it's just modeling, it's giving you an approximation that's close to the actual data. So 15 years, let me change colors so it stands out for you. 15 years after marriage corresponds to this X value of 15. So we can see that our red graph intersects about right here, which I've gone downhill a little bit towards the y-axis, probably about 57%, I'd say. And you know, you can be within a few degrees here and there because we're eyeballing this. We're kind of looking at, we're eyeballing it from the graph. So my graph tells me that about 57% end in divorce after 15 years of marriage if the girl was less than 18 when they got married. The last question says, does the given model, mathematical model underestimate or overestimate the actual percentage? It overestimates. This is our mathematical model right here, 65%. Our actual is 57, so it overestimates by about, looks like about 8. So approximately, that's what the wavy line says, approximately 8%. It overestimates. Any questions about that? Taylor says, I'm good. Dave says no questions. LaToya say no questions. The last slide is just some reminders for you. All orientation materials are due by this Sunday. Now, I've had a few people email me about the homework help video. You do not have to schedule that for this next week. That can be scheduled any time during the semester. I would like you to go ahead and schedule it, but the scheduled time that we're going to meet can be any time this semester that I have open. If you need an appointment outside of my office hours, just email me and I'll set something up with you. The homework help video, you're going to be bringing in 3 questions that you have from the homework at that time. So whatever section or unit we're in, you'll choose 3 questions and bring them with you to the help session. Together, we'll choose 1 problem to work through together. And I'll make a little video using my tablet here and Collaborate. We'll record our session so that we can record how to solve this problem. And then I'll post the video for everybody to benefit from. So that's the homework help video, and that's the one I've gotten the most emails about. So you don't have to schedule it for us to meet next week, but you do need to go ahead and get it scheduled. And I've already had some people schedule. So the earlier you schedule that, how do we set that up again? D2L. It is not in D2L. It's called the WASP appointment scheduler. I will post a video this weekend in the news feed showing you how to do that. There's a link in D2L that takes you to the appointment scheduler, but it can be tricky. just to let you know, you need to sign in as a guest. If you don't go in as a guest, you'll have to put in a password. You don't need all that. Just sign in as a guest, and you will be able to see my appointment blocks and choose one. They're in 30-minute blocks. Okay, next announcement, Unit 1, which is 1.1, 1.2, and 1.3, the homework and the quiz are due for that particular unit, not this Sunday, but next Sunday, the 26th at 11:59 p.m. The quiz will be open in my math lab on the 22nd. It stays open for 5 days. You have 2 attempts at the quiz. You don't have to take 2 attempts. If you're happy with your first grade, stay there. If you do make a second attempt, I will average the 2 grades to get your quiz grade for that unit. And the next lecture will be this next Monday at 3 o'clock, and I'll be covering section 1.2. If none of y'all have any questions, I'll say have a good day and have a good long weekend. If you have face-to-face classes, don't go to school on Monday. It's MLK Day. You'll be very lonely. Bye, LaToya.